This video will review how to solve linear systems using the elimination method. Linear systems are a combination of more than one equation, for instance like this. In this case, we see that 2x plus 3y equals 8, and 5x minus 3y equals negative 1. This is a system of equations. When you have two equations, you can solve for two variables. In the past, we've used substitution method to solve this, or we've done it by graphing. Now, this would not be such a good candidate for substitution method as we do not have an x or a y by itself. None of the variables are isolated. In addition, if we were to solve for x or solve for y, we would get fractions, which most of you don't want to use. So instead, we're going to look at another method. This is called elimination. So the question becomes, do we need to rewrite the equations in order to be able to do this? Do we need x or y by themselves? And the answer is no, we don't. We can solve this another way. We can do this without rewriting either equation. In order to do the elimination method, we're going to look at a number of steps. If you're taking notes at home, I recommend that you write these steps down and use them when you start solving the practice problems. Now, as the name applies in elimination method, you want to eliminate a variable. This is like what we did in the test where we tried eliminating either the Brutus bites or the Figaro flakes, one of the purchases that matched. In order to do this using the equations, we need to find opposite coefficients for either the x or the y. We want the variables to eliminate, not the constant. So first off, we look for opposite coefficients for either x or y. We then add the equations together. This will eliminate a variable if we have opposites. If we don't eliminate one of our variables, then we need to go back and check our work. We did something wrong and it's not helping us. You need either x or y to be eliminated. You need to get it down to a single variable equation. We're then going to solve the remaining equation for the variable that's listed still. We'll then substitute this value back into either of the original equations and solve for the remaining variable. If we eliminate the y's and we solve for x, once we know x, we'll plug it back in and solve for y. We then write our answer as a coordinate. A coordinate is xy. The reason we're writing as a coordinate is we need to remember that in these problems we're finding the point of intersection. A point needs to be written in coordinate form. Let's look at an example. In this problem, we have that 2x plus 3y equals 8. The second equation says that 5x minus 3y equals negative 1. Going back to our steps, we see that the first step is to look for opposites. Opposites are when you have the same number, but one's positive and one's negative. Here, the y's are opposites. We have a positive 3y and a negative 3y. So if we add these equations together, those opposites will cancel. We're going to add the equations vertically, which means that we'll have 2x plus 5x, which is 7x. And then 3y minus 3y would be 0, so we can forget about that. The y's are eliminated. And then equals 8 plus negative 1. 8 plus negative 1 is 7. The new equation we get is much simpler, and it's just 7x equals 7. In order to finish solving the equation, which is now step 3, we divide both sides by 7, in which case we get x equals 1. Once we've solved for one of the variables, we're now going to substitute this value of x equals 1 into either of the original equations. It can go into the top or the bottom. Typically, we look for the one that's easiest. In this case, I think the top equation is easier because everything is positive. So if we substitute where x is for 1, we'll get this. 2 times 1 plus 3y equals 8. 2 times 1 is 2. In order to get y by itself, we'll subtract 2 from both sides, in which case 3y equals 6. Then we'll divide by 3 on both sides, and we get that y is 2. We now know that x equals 1 and y equals 2. This is the solution to the system. And it reflects the point of intersection. Therefore, we're going to write the point as a coordinate. It's the point 1, 2. So the last step is to make sure that we get the answer written as an ordered pair, which again is 1, 2. One last time, we need to remember what this answer means. When you solve a system of equations, and it doesn't matter whether you use elimination, graphing, or substitution method, the solution to a linear system is always the point of intersection. It's where the graphs cross. The whole reason for doing this is finding the one and only time that the graphs would be intersecting or where the values are equal. Now let's look at another example. Here's another one I want you to try now. If you need to, pause the computer, work it out, and when you're ready, hit play again. I'll wait a moment. All right, I hope you worked it out. In this problem, again, we're going to start by looking for opposites. And like the previous problem, I see that the y's are opposites. We have a positive 1y and a negative 1y, meaning when we add these equations together, the y's will cancel. Now, it's not always going to be the y's that are opposites, but the last two examples were. If we add together, the y's are eliminated, and I get that 4x equals 12. Dividing by 4 on both sides, I get that x equals 3. I can now substitute the value of x equals 3 into either equation. Again, I like the top equation better because everything's positive. Makes it a little bit easier to work with. If we substitute in the top equation, we get 2 times 3 plus y equals 7. Again, we just substituted the 3 in place of x. 2 times 3 is 6, and we'll subtract 6 from both sides to get y by itself, in which case now we'll see that y equals 1. Just remember, when you're done, you need to write it as the solution as a coordinate. It's the point of intersection. The solution here is the coordinate 3, 1. Now let's look at a little bit harder example. Go ahead and take a look at these two equations and find where your opposites are. It's kind of a trick question because right now we don't have opposites. If we don't have opposites, and we don't because 4x would need a negative 4x, and negative 3y would need a positive 3y, in which case now we're going to have to make opposites. And the way we're going to do that is we're going to multiply either one or both of the equations in order to make opposites. Now looking at the x's, 3x will not go into 4x evenly. So that's going to be a little difficult if we want to cancel the x's. But for the y's, I see that a 1y can be divided into negative 3y. 1y is a factor of negative 3y, which means if I multiply the bottom equation by a positive 3, I can make my equations cancel, in which case y's will drop out and be eliminated. Again, the reason I'm doing this is that if I have a negative 3y, the opposite would be a positive 3y. 3 times the 1y that is there would be the 3y. Now when we multiply, we need to multiply each piece of the equation. That means everything in that equation, including the right-hand side, has to be multiplied. So if we distribute 3 times 3x is 9x, 3 times y is 3y, and 3 times 5 is 15. So when we rewrite it, we need to make sure we multiply all the pieces. The top equation didn't change, and the bottom equation becomes the 9x plus 3y equals 15. The y's will eliminate, and we're left with a new equation. 4x plus 9x equals 13x, and negative 2 plus 15 is 13. Now this is going to be really quick to solve. We just divide by 13 on both sides, and x equals 1. Substituting back in, bottom equation now is probably a little bit easier, so we'll put that 1 in place of x, and we'll do it on the bottom equation. Again, we could use it for either equation, but the bottom one here is a little bit easier. So 3 times 1 is 3, which we'll now subtract from both sides, and we see that y equals 2. Again, that last step is we have to write our answer as a coordinate. The point of intersection, or the solution to this system, is 1, 2. Now let's take a look at another example. Here we have 3x plus 6y equals 12 and 4x plus 7y equals 11. Do we have opposites? No, we don't. So as we have no opposites, we need to create them. I'm going to look to cancel the x's. Here, 3x will not divide into 4x. 3x is not a factor of 4x. And 6y is not a factor of 7y. So in order to be able to do this problem, I'm going to have to multiply both equations. So it depends on which variable we want to eliminate. If we choose to get rid of x, we've got to work with that 3x and 4x. And we need to do that by finding the least common multiple. The least common multiple of 3 and 4 would be 12. Now in order to get a 12x on top, I see that we're going to have to multiply the top equation by 4. 4 times 3x would be 12x. Now if I have a 12x, the opposite of that would be a negative 12x, which means I need to multiply the bottom equation by negative 3. Now it's always going to work out that I can take those coefficients of the terms and reverse them. If neither of them is negative, then I just need to make sure one of my numbers I multiply by is a negative. I could have also used negative 4 and then positive 3. If one of the terms is already negative, then when you flip and multiply, you don't need to multiply by a negative number because you already have it. In this case, when we multiply the new equations together, we need to multiply all the pieces. So multiplying 4 times 3x is 12x, 4 times 6y is 24y, and 4 times 12 is 48. On the bottom, negative 3 times 4x is negative 12x. Negative 3 times 7y is negative 21y, and negative 3 times 11 is negative 33. Adding the equations together will eliminate the x's. And we're left that 3y equals the 15. Dividing by 3, we get y equals 5. Now I'm going to substitute this in, and this time it's really kind of none of the equations are really that much easier than the other, so I'm going to go ahead and substitute in the top equation. Again, I can use either one, whatever one I think is easier, and I think the top one's going to be marginally easier. Plugging y is 5, 6 times 5 is 30, which we'll need to subtract from both sides, and we get that 3x equals the negative 18. Dividing by 3, we get that x equals negative 6 now. And this I can use to write my solution. The solution in this case as a coordinate would be negative 6, 5. One last time, don't forget, that's the point of intersection. The whole point for solving a system of equations is to find that point of intersection. Now I'm going to put two more problems up, and I want you to go and try these ones. So if I can get this to work here. There we go. Again, I would like for you to pause the program, try the problems on your own, and then check your answers. I'll wait a moment. All right, hopefully you've tried these out. The top problem, neither one are opposites. Now I can choose whatever one I want to cancel, but I think it's going to be easier to cancel the y's. The reason I chose to do that is that I already have one that's positive and one that's negative. 3 times the negative 2y would make negative 6y. In order to get a positive 6y on the bottom, I just need to multiply by 2. Multiplying both equations out, here are my new equations, and I see that the y's are going to cancel. Adding the equations together, I get that 19x equals 19, which means that x equals 1. Substituting back in, probably to the bottom equation as everything's positive. Working it out, 2 times 1 is 2. Subtracting from both sides, you get 3y equals 12. Dividing by 3, and we get y equals 4. The solution, or point of intersection here, would be 1, 4. On the next equation, 5 will not go into 6 evenly, and 3 will not go into 5 evenly. So I'm going to have to, either, no matter what variable I pick, I'm going to have to multiply both equations. So I'm going to go with multiplying the top by negative 5 and the bottom by 3. This will cancel the y's. I could have also gone with a positive 5 and a negative 3, or if I wanted to cancel the x's, I could have gone by top by negative 5, bottom by 6, or 5 and negative 6. All right, multiplying this out, we get that negative 30x minus 15y equals 15, and that 15x plus 15y equals 15. Combining, the y's will cancel, and negative 15x equals 30. Dividing by negative 15 on both sides, we get that x equals negative 2. Again, we're not done. We need to substitute it back in. I chose the bottom equation, and I'm going to substitute that x equals negative 2. 5 times negative 2 is negative 10. Add 10 to both sides, and we get 5y equals 15. Dividing by 5, and we get y equals 3. The solution here, or the point of intersection, would be negative 2, 3. Alright, I hope this video helped you to understand how to solve linear systems using elimination method. Thanks for watching.